Okay, while waiting for the others to come, I go and get a drink, a cup of tea. Okay, all of you back. Two more missing. One more. One, two, three, four. One more. One more. Three, four. Chen Tong, I think. Okay, now can you hear me? Can you see the screen?
Yes, teacher.
Yes, you can hear, you can see. Okay, now we're going to look at the first example. Okay, so I'm going to explain to you. Uh, Chen Tong go tuition. Okay, right. I'm going to explain to you. Of course, you know what is happening lah. You know what is happening already. You know there is a normal, there is a tangent there, and we are supposed to find the equation of tangent and normal. Now, how you go about finding the equation of tangent and equation of normal, right? So do you make use of these three things here? Okay, so the example number 34 is here. Find the gradient function of the curve y equals to 3x minus 1 raised to the power of 5. This is the first step lah. They didn't ask you to find the tangent yet, right? Now, gradient function. What is meant by gradient function? Gradient means dy dx lah. Function means your dy dx is not a fixed number. It is a function of x. It is expressed in terms of x. Okay, now, so if they ask you to find gradient function, means they ask you to find an expression involving x, and this expression will give you the value of the gradient if you substitute a particular value inside that function. Okay, so now I know this is about dy dx. So once I see the question, I differentiate the y. Differentiate the y, bring down 5. Then inside the bracket, I copy the 5 less by 1 becomes 4. Then I differentiate what is inside the bracket. So 3 times 5, 15. 15 bracket 3x minus 1 raised to the power 4. Now this is dy dx. This is the gradient of tangent. But this gradient of tangent is expressed in terms of x. So it is a function of x lah. That is why it is called gradient function. So the gradient function is this thing. Any question?
So teacher just differentiate, then we will get the gradient function.
Function, you just leave it in terms of x.
Okay.
Okay. Function, you just leave it in terms of x. So we look at the next question, 35. What is question 35 on this side? Find the gradient of the curve y equals to this thing when x equals to -2. Now, if you read question number 35, they say find the gradient. No longer gradient function. So find the gradient means you have to find the number lah, the number that represent the gradient, right? Okay, right. So this is the equation y equals to 3x minus 5 over x squared. Now, although this is the quotient of two functions, but because the denominator has only one term there, I can actually split them up and make them very easy. No need to use quotient. Is that okay or not? Are you wise enough to see that this no need quotient rule? If you have been practicing, then you can see no need quotient rule, right? So I split up term by term like that. 3x divided by x squared is 3 over x. Negative 5 over x squared is negative 5 over x squared, right? So this is the y. I want to find dy dx. So differentiate the first term here. Oh, this is negative 1. Bring down negative 1, become negative 2. This one is negative 2. Bring down negative 2, become negative 3. So simplify. Okay, I simplify and multiply this together, become negative 3. Negative 2 goes to the bottom, x squared. Negative 5 times negative 2 become positive 10. Then negative x power 3 goes to the bottom. So this is my dy dx. This is my gradient function. What they want? They want the gradient at a particular point x equal to 2. Now, I substitute x equals to 2, right, into this dy dx. I find, 3 over 4. This one, 10 over 8. 10 over 8 is actually 5 over 4. 5 over 4, 3 over 4, the denominator is the same. So 5 and 3 become 8. 8 over 4 become 2. Right? So you do some mental calculation. Okay, now there's one thing I want to tell you. Now they give you only the x coordinate. Now if you look here, the point on the curve has two coordinates. You have the x coordinate and the y coordinate. Right? Now in the question that we have seen just now, they gave us only the x coordinate. Now if they want you to find the y coordinate, you need to substitute the x inside the original function, not the differentiated function, into the original function and find the value of y. Right? You see here I give you two values, the coordinates x and y. But here, over here in question number 35, they give you the value of x and they want you to find the gradient. So it is not necessary to find the y coordinate. But if they ask you to find the equation of tangent, you need to find the y coordinate. How to find the y coordinate? You have to substitute the x into the equation involving y, and it will give you the y coordinate. Li Ying, you remember the previous exercise? There's one question like that. Ask you to
Yes.
find the y
Yeah.
coordinate. Yes. You don't substitute into dy dx. You substitute into the original y. And with that, you know a pair of coordinates. So this pair of coordinates is used to find this, right? This equation of tangent. But in this case, no need yet, no need yet. So you see that the questions here, I grade them accordingly. The first one just ask you to find the gradient function. The second one just ask you to find the gradient. So what is going to happen to the third question? Third question, do what one? Question number 49. Okay. Now this 49, they ask you to find the equation of tangent already. So let me read to you question number 49. Now on your screen, can you see the words? Because after zooming, your screen is not the original one, right?
Can.
Can
Can.
you read the words here?
Yeah,
Can.
can, teacher.
Can. Okay. So I read, find the equation of tangent to the curve y equals to 2 over x plus 4 over x at the point 1, 6. So in this question, you are given the point both x and y. So you don't have to find the y lah. Don't need to find y because it's given, right? So give both x and y, right? And you are asked to find the equation of tangent, right? So I refer to the notes here. You refer to the notes on the left hand side. To find the equation, you need to find the gradient. You need to know the point. You know the point already, 1, 6. Do you know the gradient? Don't know. So you have to find the gradient. Okay, so the question is over here. I copy down the question, 2 over x plus 4. So since I need to find the gradient of tangent, I have to differentiate. To differentiate, I have to find dy dx. The dy dx is what? 2 negative 2 over x squared. Differentiate 4x become 4. So this is my dy dx. It is gradient function. It's not the gradient yet. So I need to substitute in a particular value of x to find the gradient. So that particular value of x is 1. Okay, 1. So I substitute 1 inside here. 2 over 1 is 2. 4 minus 2 is 2. So now I know the gradient of tangent is 2. So quickly I write down there m equals to 2. I know the gradient of tangent. Okay, I need one more thing to find the equation of the straight line. So that one more thing is the pair of coordinates. So the pair of coordinates is 1, 6. So m2 coordinate 1, 6. So all these three numbers I substitute into the formula. So the three numbers, y minus y1, y minus y1 is 6, m I replace with 2, x is x, then x1 is 1. So finally, because the tangent comes from the gradient of tangent, the gradient comes from gradient of tangent, the point comes from the point on the line. So this is the equation of tangent. So this is it, equation of tangent, right? Simplify, you get equation of tangent. Any question? First, find the,
Teacher,
yes,
can you repeat question 49?
question 49. You are given the equation of the curve, right? From this equation of the curve, you need to know two things. Show my face so that you know what I'm talking about. Now, you are given the equation of the curve. Now, from this equation of the curve, you need to know two things. Number one, the gradient. Number two, the point. So if you know the gradient and the point, using the formula that I've given you there, you can find the equation of tangent. Right? You must know gradient and point. So you semak. Oh, the point is given. So no need to find the point already. You need to find the gradient. Then you ask yourself, how to find the gradient? Find dy dx. So you find dy dx. After finding dy dx, you put in x equals to 1. You can find the numerical value, that specific value of the gradient of tangent. Answer is 2. So using this number 2 and the given point, you substitute into the formula, that will be the equation of tangent. Any question?
Okay, understand, teacher.
Okay, understand. Okay, right. So okay, now we go on to the next question, number 50. What is this number 50 all about? Huh? Okay, number 50 say find the equation of normal to the curve at this curve lah, at the point 0, 4. 0, 4. So again, when they ask you to find equation, you think of gradient and point. Do you know the gradient? Don't know, right? Don't know the gradient. Do you know the gradient? Don't know the gradient. Do you know a point on the line? Yes, you know the point line. So what must you do now? Point already known, only gradient don't know. So what must you do? Find the gradient. How to find gradient? Find dy dx. Okay, find dy dx. Okay, so how to find dy dx? You differentiate. And when you look at this equation here, the equation of the curve, although it is a quotient of two functions, but the function at the top is a number, so you don't have to use the quotient rule. You express this in the form of a composite function, right? So you make it into a composite function and you differentiate, right? So bring down the -2, then this one decrease by 1 become -3, then differentiate inside the bracket, then you get another 3 again. Now all these numbers 4, -2 and 3, they are at the top there, they are the numerator, so they become -24. Now this term here, this bracket here, is raised to the power of -3, so it goes to the bottom. So this is dy dx. dy dx is the gradient function. It's a gradient function. So this gradient function, uh, unless you substitute numbers inside, you cannot find the gradient, right? So I substitute the number. What's the number for x? Oh, 0, 4. So the number is 0. I substitute 0 inside. 0 minus 1. 0 minus 1 is -1. -1 raised to the power of 3 is still -1. So negative become positive, right? And positive 24 over 1 is 24. So the gradient of tangent is, I call it m1. Remember, gradient of tangent, I call it m1. So m1 is 24. What is m2?
Gradient of the normal.
Gradient of the normal. Now, how you find the gradient of normal? Very simple. You just take that number, you invert it. Invert means terbalik lah, terbalik the number. Not only terbalik the number, you terbalik also the sign. So positive 24 becomes, you terbalik the sign, it becomes negative. Then the 24 you terbalik become 1 over 24. Is that okay? Don't have to calculate one. You just try to imagine like that. Now let's say if my m1, let's say if my m1 is let's say negative 4 over 5. Negative 4 over 5. What do you think is the m2? Take the number, terbalik, the sign also terbalik.
5 over
If positive, you say negative. If negative, you change to positive. So what's the answer? M2.
5 over 4.
5 over 4. Positive 5 over 4. So it's as simple as that. So don't try to go and calculate and find the gradient of normal. Just terbalik the number, terbalik the sign, you will get answer. Okay, so the gradient of normal is -1 over 24. So coming back to our formula, y minus y1, mx minus x1. The point we know is 0, 4. The gradient we know is -1 over 24. So all these three numbers, you substitute into the formula. right? So substitute into the formula, become y minus 4 equals to negative 124, x minus 0, right? X minus 0. So simplify, you have equation of normal, y equals to negative 124x plus 4, right? Okay, now actually, okay, any question first? Any question?
No,
Others?
teacher.
No question, can understand. Can understand. Okay, right. If you can understand, that means I want to summarize. Okay, I want to summarize the thing that the type of question that you have encountered. Find the equation of tangent. Find the equation of normal. Equation of tangent, differentiate and you get the gradient of tangent. Now for equation of normal, there's one more step. You have to take the equation of the gradient of tangent, you terbalik it, make it into gradient of normal, then only find the gradient. One more step, right? But in the exam, they're not going to give you so simple questions. They're going to make it very difficult for you. Huh? How are they going to make it difficult? Oh, maybe I ask you to do the simple one first, before I show you the more difficult ones. Okay. Yeah. So this, how many minutes left? Is there any time to? I don't know how much time we have. Never mind. Don't know how much time. Now, you look at this self exercise 2.8. So the homework for today is self exercise 2.7, self exercise 2.8. You try the simple one first, equation tangent and equation normal. You try number 1a and number 1b. Okay, find the equation of tangent, equation of normal. Oh, the more difficult one will be like this. You see here, self exercise 2.7. You see here, the curve ax squared plus box has gradient and so on. Find a and b. You see, the exam questions are normally in additional mathematics. They like to put in a lot of unknown there, a, b, c lah, m, n lah, x, y lah, like that to make you. Okay, so I want to show you examples where you need to find the unknown inside the curve. But before I show you this type of question, can you please try number 1a and number 1b? Both also you need to find tangent and normal, equation of tangent and equation of normal. You try first, number 1, right? Self exercise 2.8, number 1a and 1b. now you try A enough like that. You try A, 1A enough.
Teacher,
Yes,
eh, to
1A.
find the equation of the tangent,
Yes.
not just differentiate the function.
Yeah, differentiate. Okay, differentiate. So your dy dx is 10x minus 7.
Teacher, but
10x
the
minus 7.
the answer not 10x minus 7.
Uh, the point is 1, negative 3. So x
Yeah,
equals to 1. X
yeah.
equals to 1. So what is your
The answer I get 10x minus 7. I get 10x minus 7, but the answer behind is 3x minus 6.
10x minus 7? Never mind. Huh? So you're looking at the wrong answer maybe. Right. So when now the point is x equals to 1, right? X equals to 1. So what is my m1? What is the gradient? So you substitute 1 inside here. Substitute
3.
1 inside here. So it's 10 multiplied with 1 minus 7. So answer is 3. So this
3.
is the m1. Hmm? What's the m2? What is m2?
That 2 is negative 103.
Correct. Negative 1 over 3. Negative 1 over 3. Okay, right. So then we can proceed to find the equation of tangent. Equation of tangent, right? Y minus, what
2.
is the y coordinate?
Y coordinate is negative 3.
Correct, negative 3. What is the gradient of tangent? Gradient of
Um,
tangent is 3.
3.
X minus, what is the x coordinate? 1.
1.
Okay. So now you can see the gradient, the equation of tangent y equals to 3x. Okay. Then the 3 times 3 is negative 3 lah. 3 times 1, negative 3. This one is positive 3, bring over negative 3 become negative 6. So this is the equation of tangent. How about the equation of normal? Have you found the equation of normal? Equation of normal. Okay, equation of normal. Y minus negative 3 equals to the gradient. Gradient is negative 1 over 3. 1 over 3. Then x minus 1. X minus 1. Okay, x minus 1. This one is x. Okay, right. Now how to simplify? Y, y plus how many? 3. Y plus 3 equals to this thing. This thing. Copy, then paste here. Okay, right.
Negative.
So I multiply by 3. 3y plus 9 equals to negative x plus 1. Is this okay? The 3 I bring to the other side, the negative I multiply in
Uh,
this. So
okay.
x plus 3y plus 8 equals to 0. This is the equation of normal. Okay, so this is the equation of normal. Right. So the answer you see at the back is not the gradient function. It should be this one, the equation of tangent and equation of normal, right?
Okay, teacher.
Okay, now you look at this one, question number 46. The gradient of normal to the curve a plus x squared plus b at the point 110 is -8. Find the values of a and b. So here they didn't ask you to find gradient, they didn't ask you to find the point, they didn't ask you to find the tangent. They asked you to find a and b. Now how to
Teacher,
proceed like that? Hmm?
question 46 ah.
46. Can you see 46 or not?
Can.
Okay. So you are given an equation with a and b there. Then they give you a point, they give you a gradient. Find a and b. Now, oh dear. Okay. Right. Only 8 minutes left. I think we cannot proceed really. If I go and reverse the car, come back, more than about 5 minutes, 3 minutes left. This question I show you next week. Okay, so we can end the lesson here already. Right?
Okay,
Can end the
teacher.
lesson now.
Thank you, teacher.
Thank you. Bye.